Welcome to the Introduction to Drug Dosage Calculations workshop presented by Germanna Community College Tutoring Services. Today we'll be talking about the 3 units of measurement, metric conversions, converting between units. We will use these conversions to perform drug dosage calculations, and we will use 4 separate methods to do these calculations. We will also discuss oral dosages, parenteral dosages, and reconstitutions. The 3 units of measurement are household, apothecary, and metric. The household unit is what we normally use within our houses. Teaspoons, tablespoons, cups, quarts, glasses, that type of thing. These numbers, you can use whole numbers, you can use fractions, you can also use decimals. The number comes before the unit. An example would be 1½ tablespoons, where we put the numeric value 1½ before the letter T for tablespoon. The apothecary system is an older system. The apothecary system is an approximation, and we use whole numbers, fractions, and Roman numerals. You are not allowed to leave the apothecary system in decimal form. With the apothecary system, the numeric value comes after the unit. An example would be grain 15 or dram 1½. With the metric system, you can use whole numbers and decimals. The whole number and decimal will always come before the unit. You must also remember when you're using a decimal to put a 0 in front of the decimal. This ensures there are not medical errors. An example would be 0.15 milliliters. With metric conversions, you are only required to know 4 of the prefixes to go with the bases: the kilo, your basic unit, milli, and micro. With all 4 of these, there are 3 decimal places in between the conversions. To convert from one metric unit to another, you only have to move the decimal place 3 places in the direction you want to go. For example, if you have a microgram and you're trying to convert it to a milligram, you simply move the decimal 3 places to the left. When you convert between units, you must have a conversion factor to eliminate the given unit of measurement. A conversion factor is a known relationship, such as 1 foot is 12 inches. There are 3 ways to set up a conversion factor. We know that 1 kilogram equals 2.2 pounds. We can use an equal sign to show this relationship. We can also use a colon to show the relationship. Or we can create a fraction to identify a relationship between kilograms and pounds. There are 4 separate methods to do these conversions. The ratio method, which is also known as the rainbow method, is used by setting up our conversion factor with colons. We know that 1 kilogram is to 2.2 pounds. We can place an equal sign and put a calculation we're trying to figure out, such as 12 kilograms is an unknown number of pounds. Notice that the order of units is the same on both sides of the equal sign. Kilograms is first on the left, and kilograms is first on the right. Pounds is second on both sides as well. With the proportion method, you will be using fractions. We can state that 1 kilogram is the same as 2.2 pounds by creating a fraction. We can place an equal sign and put our unknown on the right side. Notice again the order of the units. On both sides of the equal sign, kilograms is on top in the numerator, and pounds is on the bottom in the denominator. If you choose to use dimensional analysis, you're going to start with the number you're trying to change, in this case 12 kilograms. You will then multiply by your conversion factor in the form of a fraction. This time, however, we want our units to cancel out so that they have to be in the opposite places in the fraction. Since 12 kilograms was on top, we're going to put the 1 kilogram at the bottom so that the units cancel out. With the formula method, you are using the formula of the dosage ordered over what's on hand times the quantity it's available in. In the case of taking the 12 kilograms, we would start with the 12 kilograms ordered over the 1 kilogram we know times the 2.2 pounds we're trying to change it to. Let's go through an example of each one of these. Let's use the ratio method to take 10 kilograms and convert it into pounds. Our first step is to find our conversion factor. We know that 1 kilogram is the same as 2.2 pounds. We then must set up our problem. We know 1 kilogram is to 2.2 pounds. We'll place our equal sign. Since kilograms was first on the left-hand side, kilograms has to be first on the right-hand side. We put our 10 kilograms, a colon, and use X to represent the unknown number of pounds. You then multiply your means and your extremes. That's the insides and the outsides of your rainbow. We multiply the 1 kilogram times the X pounds and the 2.2 pounds times the 10 kilograms. We then solve for our X by multiplication and find out that 10 kilograms is the same as 22 pounds. A second way to do this conversion is by use of the proportion method. We again will take 10 kilograms and convert it into pounds. We know our conversion factor is 1 kilogram equals 2.2 pounds. We can then set up our proportion. We create a fraction showing the relationship between kilograms and pounds. We know 1 kilogram is the same as 2.2 pounds. We place our equal sign. Since kilograms is on top in the numerator on the left, we're going to put our 10 kilograms in the numerator on the right. Since our pounds is at the denominator on the left, we will do the same with the pounds on the right-hand side. From here, we cross multiply. 1 kilogram times X pounds equals 2.2 pounds times 10 kilograms. You may then solve for X, and we find that 10 kilograms is equivalent to 22 pounds. A third method of doing this calculation is by use of dimensional analysis. Again, we are going to convert 10 kilograms into an unknown number of pounds. This time, we're going to set up our problem by starting with the item we're trying to change, in this case, the 10 kilograms. We will then multiply by our conversion factor in the form of a fraction, the 2.2 pounds over the 1 kilogram. We make sure we place the kilogram at the bottom so that the kilograms cancel out and we are left with pounds. From here, we multiply across both the top and the bottom, and then simplify. We find that 10 kilograms is equivalent to 22 pounds. The fourth method you may use is the formula method. We can again take 10 kilograms and convert it into pounds. We will do this by setting up a formula. We will start with the 10 kilograms as that's what we're trying to change. We will then put the matching unit of our known conversion factor right underneath it, the 1 kilogram. We will then multiply by what we're trying to change it to, 2.2 pounds. We will then multiply across and simplify, and we find that 10 kilograms is equivalent to 22 pounds. There are many types of drug dosage problems that use these conversion methods. Are simple conversions, oral dosages, parenteral dosages, and reconstitutions. We can use conversions to solve oral dosage problems. Suppose we have an order of 500 milligrams of Tylenol. We have available 200 milligram Tylenol tablets. Well, we have to ask ourselves, what do we really need to do here? In this case, we must change 500 milligrams into an actual number of tablets to administer to our patient. We must then search for a conversion factor relating the milligrams to the tablets. We can see by the bottle that we know that 1 tab is the same as 200 milligrams. This can be written in all three ways. The 1 tab equals 200 milligrams, 1 tab colon 200 milligrams, or 1 tab over 200 milligrams. You will then use that conversion factor to convert the 500 milligrams into tablets. All 4 methods will result with the same answer. I encourage you to stick with the same method every time that you do these conversions, as it will be easier for you in the future. No matter which method you use, we will find that 500 milligrams is the same as 2.5 tablets. Sometimes you might have to solve oral dosages that use more than one conversion. An example would be if I had an order of Dilantin, grain 1, by mouth 3 times a day. We have available Dilantin 30 milligram capsules. We first ask ourselves what we have to do here. I know I need to give grain 1 to our patient. So I must figure out how many capsules I need to administer the client grain 1 of this medication. In this case, there are 2 conversion factors we're going to have to use. Unfortunately, we don't know the grains in the capsules. However, we do have a relationship between grain 1 and 60 milligrams, and we also know that 30 milligrams equals 1 capsule. The grain 1 equals 60 milligrams is a conversion factor you need to memorize. The 30 milligrams equals 1 capsule we get from the bottle of medication. We will first convert grain 1 into milligrams using the conversion factor of grain 1 equals 60 milligrams. The second thing we will do is use the conversion factor of 30 milligrams equals 1 capsule to convert 60 milligrams into capsules. By doing so, we find that 60 milligrams is equal to 2 capsules. It doesn't matter which method you use to do these calculations. Again, all 4 methods will result in the same answer. We can also use conversions to solve parenteral dosage problems. For example, we have an order of Visceral 20 milligrams IM every 4 hours as needed for nausea. Our supply is a 10 milliliter vial of 25 milligrams per milliliter. First, we must ask ourselves what we need to do. We need to figure out how many milliliters of medication to administer to our patient for them to receive 20 milligrams of this medication. Therefore, we must find a conversion factor that relates milligrams to milliliters. If we look at our supply, we see that there are 25 milligrams per 1 milliliter. We can convert 20 milligrams that was ordered into milliliters by using the conversion factor of 25 milligrams equals 1 milliliter. You may use any of the 4 methods that we discussed. Whichever method you use, you still result in 0.8 milliliters. Reconstitutions are drugs that are packaged as powders and must be reconstituted before administered to a patient. The label will tell you a few different things. It will tell you how much the quantity of the drug that's in the vial or ampule. It will also tell you the amount and what type of diluent to add to the powder. And it will tell you the strength of the resulting solution. All of this information is important, but when it comes to measuring out the correct liquid dosage, you are only concerned with the strength of the resulting solution. Key words would be like the solution results in, or words like yield or after prepared. For example, your patient needs 25 milligrams of gentamicin IM. The label says to add 1.3 milliliters of sterile diluent to yield 50 milligrams per 1.5 milliliter. How many milliliters of reconstituted solution do we need to give? Well, from the question we can tell we need to change 25 milligrams into a certain amount of milliliters in order to give it to our patient. We must then look for that conversion factor, the relationship between milligrams and milliliters. In this case, we can tell by the wording that our solution is going to yield 50 milligrams for every 1.5 milliliters. We will then set up our conversion to convert the 25 milligrams into milliliters with our known conversion factor of 50 milligrams to 1.5 milliliters. All 4 methods will result in the same answer. In this case, 0.75 milliliters. Remembering, Tutoring Services offers you many different resources. We have hallway handouts that you can pick up for more practice or download offline. 2 of these are how to solve drug dosage problems, as well as drug dosage practice problems. We also have one-on-one tutoring as well if you feel that you need more explanation. Feel free to stop by room 208 at either the Locust Grove campus or the Fredericksburg area campus, Building 1.